Welcome to the Deep Dive. Today we're tackling a really vital industry: construction.
Absolutely vital. It literally shapes the world around us.
It does. And just think about the scale in Great Britain alone, something like 2.2 million people.
Yeah, contributing around, what, 97 billion to the economy? It's huge.
A massive engine for progress. But, and this is the tough part, it's still one of the most dangerous jobs out there.
Tragically, yes. Construction accounts for about a quarter of all fatal injuries to workers.
And that's not even counting things like occupational lung disease or
Yeah.
those musculoskeletal disorders that can be really debilitating.
Exactly. The human cost is immense, and honestly, the economic fallout isn't small either.
Yeah.
Lost productivity, insurance, it all adds up.
It really does. So it feels like an industry just crying out for a revolution in safety.
It is. And the potential for improvement is enormous.
Which brings us to our mission for this deep dive. We're looking at how a specific standard, PAS 11926, coupled with Building Information Modeling BIM, is really changing the game for health and safety.
Fundamentally changing it right across the whole life of a building or asset.
And this isn't just about, ticking compliance boxes. It's about making projects genuinely safer, smarter, and crucially more collaborative for you, the listener, involved in these fields.
Collaboration is key.
So today we'll explore why safety needs this digital upgrade, dig into the PAS standard itself, see how it works in practice with things like risk cycles and real examples, and finally, look at what this means for the future.
Sounds like a good plan. The traditional ways honestly just aren't enough anymore.
Right, stacks of paper documents, separate silos of information. It has its limits, doesn't it?
It really does. When we talk about a digital upgrade, the real magic isn't just swapping paper for PDFs. No. It's about making that safety information intelligent. Imagine every risk, every safety procedure isn't just text, but structured data.
Okay, structured data. What does that unlock?
Well, it means the data can be actively shared instantly across all teams, all software.
So interoperability.
Exactly. It boosts efficiency, allows for automated checks like spotting clashes before they happen on site, and builds real confidence because everyone's working from the same reliable information.
So data captured once can power multiple safety processes.
Precisely. Many outputs, many checks, many workflows. It's moving from hoping someone reads a warning to the system actively flagging risks.
That's a powerful shift. Active intelligence versus passive information. And it's not just industry buzz, is it? Governments are involved.
Oh, definitely. The UK government, for example, acts as a huge client for construction.
Right, and they set a vision for BIM level 2, didn't they? Aiming for better cost, value, carbon performance.
Yes, and crucially, they did this by expecting open, shareable asset information.
Open and shareable. What should our listeners take away from that?
That the government as a client is driving demand for non-proprietary standards. It's not about mandating specific software, but ensuring everyone can share information, including safety data, using a common digital language.
Which leads us perfectly to PAS 1192-6. How would you introduce that standard?
Think of PAS 11926 as the rule book or the specification for sharing and using health and safety information collaboratively within that BIM environment.
So it's the how-to for digital safety in BIM.
Pretty much. It sits within the wider UK BIM framework and lines up with the international ISO 19650 standards that cover information management across the whole asset lifecycle.
Okay, let's unpack that a bit more. How does it fit with existing UK regulations like CDM 2015 or the MHSWR from 99? Is it replacing them?
Not replacing, no, it enhances them. But with a key difference in philosophy. CDM is law based on cooperation, basically, don't hinder others.
Right.
PAS 11926 is about best practice based on collaboration, actively working together.
A subtle but important distinction.
Very. The core aim of PAS is to bring those traditional CDM documents, pre-construction info, construction phase plan, H&S file, into a common data environment, a CDE.
The CDE again.
Yes, but not just as static files.
Yeah.
As active structured data that can be shared easily, usefully, early, and often.
So moving beyond just compliance towards proactive integrated safety.
You've got it. The benefits are clear. Integrating H&S into BIM, managing that collaborative sharing, handling safety info, flexibly, documents, models, COBie data.
COBie data. We'll come back to that.
We will. And it stresses appropriate and proportionate use. You tailor it to the project's scale and risk. Plus, a big emphasis on participation and inclusion. Everyone involved needs to benefit and contribute.
It sounds much more dynamic. And central to this is the risk information cycle, right? The IUSG model. Identify, use, share, generalize.
That's the engine of the process, yes, an iterative cycle.
Let's start with the identify. What does that involve?
Okay, so first, we define risk in the usual way, probability times severity of harm. But PAS 122.6 puts special focus on elevated risks.
Elevated risks.
These are the ones you actively share information about because they're exceptional, maybe potential for fatality or life-changing injury, or they're not obvious, or they just remain a concern despite controls.
And identifying these isn't just like checklists and experience anymore. I saw mentions of LiDAR, photogrammetry, 3D scanning.
Those technologies are huge advancements. LiDAR can precisely map a complex site, revealing hidden hazards. Photogrammetry gives you detailed 3D context.
Wow.
But fundamentally, before you identify specific risks, you need to establish the context information. Describe the facility, the project, the site. That's your consistent benchmark.
Right, context first. Okay, so we've identified the risks. Now the use, this is where it gets practical, right? Applying that information.
Exactly. And this is where the principles of prevention come in, often remembered as ERIC.
Eric.
Eliminate the hazard if possible. Reduce the risk. Inform people about it. And control the risk.
Eliminate, reduce, inform, control. Got it.
And BIM gives us powerful ways to use risk info, according to Eric. We can run auto queries in the model clash detection, checking safety zone infringements.
Finding problems virtually before they happen physically.
Precisely. We use 3D and 4D models, adding time to visualize safe work methods, sequence construction safely. Imagine animating a complex lift to ensure clearance.
That visualization must be incredibly helpful.
It is. We also see digital permit-to-work systems becoming common, and apps allowing site teams to instantly access the latest H&S info or upload observations. The goal is always inherently safer design. Bake safety in early.
Makes sense. So identify, use. Next is S-share. You've mentioned sharing early and often. The CDE is key here.
Absolutely central. The CDE becomes that trustable single source of information. No more conflicting versions of documents.
How does sharing work in practice within the CDE?
It's managed through structured, secure CDEs with clear access controls. You can visualize design assumptions and those elevated risks directly in the models, showing the agreed mitigation measures.
So you can see the risk and the solution in context.
Exactly. Digital method statements get boosted with 3D or 4D animations. Think how much clearer that makes a complex procedure. And automated notifications can ping relevant people about critical tasks or changes in risk.
Keeping everyone in the loop automatically. Very smart.
It avoids dangerous assumptions or people working off old information.
Okay, identify, use, share. And the last step, G, generalize. This feels like the long-term payoff.
It absolutely is. This is about turning project-specific learning into reusable knowledge. Lessons learned, good practice, innovations.
So it's not just solving problems on one project, but improving for the future.
Precisely. For the organization, future projects, even the whole sector.
How do you capture that knowledge?
You can extend the CDE structure to include specific fields for learning points. You might create generic visualizations of a successful mitigation strategy. And crucially, you foster open learning.
Open learning.
Sharing anonymized data or findings with industry bodies, like structural consultants sharing insights with SCOSS, the Standing Committee on Structural Safety.
So one project's near miss or success story helps prevent accidents on future projects across the industry.
That's the goal, a continuous improvement loop driven by shared data.
That's powerful stuff. Now, how is this risk information actually structured technically within BIM? You mentioned property sets.
Right. Risk needs to be described consistently. PAS 1192-6 defines a standard property set called HS Risk UK for the IFC data schema.
IFC Industry Foundation classes, the common language.
Correct. This property set includes attributes like risk name, category, description, and importantly, what it's associated with a product, an activity, or a location.
Product, activity, location.
Yes, plus agreed mitigation, likelihood, consequence, level of risk. For likelihood and consequence, often a simple 5-point scale is used very high down to very low.
Why qualitative scales?
It sparks better discussion and prioritization among the team, rather than getting bogged down in trying to precisely quantify every single risk. It helps focus effort where it's needed most.
Okay. And there's a mnemonic to help remember those associations, Pally.
Yes, Pally. Product, activity, location, legislation, emergency.
And you said PEL is key for BIM integration.
Exactly. Product, activity, location. Is the hazard linked to a specific product, like asbestos-containing material, or an activity like manual handling, or a location, like a confined space?
Nice.
Making that association clear, whether as text, an attribute on a model element, or an object relationship, is what lets us manage risk information digitally with such precision. Filter, sort, track.
It makes the risk tangible and manageable within the digital model. Okay, theory's clear. Let's talk real world. How does BIM actually work in action on projects?
Well, as we said, risks can be shown visually in the model, maybe specific symbols, not just as text attributes in the background. And those 3D and especially 4D models are game changers for spotting and solving issues virtually.
You mentioned some examples earlier, like the National Grid e-ring project.
Right, a simple one, but effective. During a design review using the 3D model, they realized a railing needed a gate for safe access. Easily fixed in design, much harder and riskier to fix later on site.
And the M5 smart motorway. That sounded dramatic.
It was a great example of 4D. Modeling the lift of huge gantries showed the crane arm clashing with live traffic lanes in the simulation.
Wow. What happened?
Seeing that visualization led the joint venture, Balfour Beatty VinCI, to collaboratively agree on a full motorway closure for those specific lifts. A safety-first decision directly enabled by the 4D model.
Incredible. And the London Victoria Station upgrade. Tunnels.
Yeah, Transport for London used BIM to manage complex jet grouting needed for tunnel stability. The model helped pinpoint potential gaps in the treated ground.
Preventing what? Grain collapse, water inflow.
Potentially all of that. Identifying those gaps in the digital model was critical for ensuring the ground treatment was complete and safe before excavation.
BIM seems tailor-made for complex projects. What about offsite construction?
Huge benefits there. Nomenka's water treatment works. GSK's factory in a box BIM makes prefabrication much smoother.
How does that improve safety?
Drastically fewer hours worked on the hazardous construction site itself, fewer heavy deliveries. GSK even used color coding linked to the BIM model so non-construction specialists could assemble modules safely and correctly. Reduces risk, reduces carbon, saves time and money.
That's a win-win-win.
Yeah.
And you mentioned VR training.
Yes. Back at National Grid e-ring again. They used VR to train people on high-risk pipeline pigging.
Pigging?
Sending a device, a pig, through a pipeline for cleaning or inspection can be hazardous. So training in a safe, simulated VR environment first builds competency before they face the real thing, reduces errors, increases confidence.
And looking even further ahead, augmented reality.
AR has huge potential. Imagine pointing your tablet at a wall and seeing the pipes and wires hidden inside overlaid perfectly, or visualizing how a finished component will fit before it even arrives on site. Great for hazard evaluation and checking designs.
So we have these amazing visual tools. But what about exchanging the underlying data, especially for the building's operational life? You mentioned COBE earlier.
Right, COBE Construction Operations Building Information Exchange. It's essentially a structured spreadsheet format, though it can use IFC too.
What's its purpose?
It's designed to hand over key asset information, mostly non-geometric, from the construction team to the building owner or operator. Think equipment lists, maintenance schedules, warranties, and safety information.
How does safety fit into COBE?
There's a specific issue sheet often used for risks. COBE fields map neatly to risk attributes we discussed. Type can be risk category, risk can be the level of risk, and so on. It provides structured hazard data for long-term facility management.
And the Team 2100 project is using this.
Yes, the Environment Agency's Thames Estuary Asset Management 2100. They're pioneering COBE to manage hazard and risk info for flood defenses over a 100-year time frame. Talk about starting with the end in mind.
That's incredible foresight. So looking at that bigger picture, what are the fundamental principles driving BIM's future in health and safety?
Well, the core BIM ideas remain constant. Start with the end in mind, forcing safety considerations earlier in design. Focus on people, processes, and technology. It's a socio-technical system, not just software.
Collaboration is key too, you said.
Absolutely. Collaborative engagement across the whole supply chain. Valuing digital assets and having clear information requirements. And increasingly, a security-minded approach, ISO 19662-5, to protect that valuable digital information.
And there are bigger forces at play driving adoption too, right? Global trends.
Definitely. Things like rapid urbanization, the need for sustainability, the shift towards a circular economy, rather than make waste.
How does BIM help with those?
Well, for the circular economy, BIM provides precise data on materials used, what they are, where they are. That's vital for future deconstruction, reuse, and safer handling of materials at end of life.
And sustainability.
BIM enables accurate carbon calculations, energy performance simulations, helps us design buildings that are not only safer, but also much greener.
So the ambitions are still growing. The UK government strategy talked about BIM Level 3, Digital Built Britain, saving billions.
The trajectory is clear. Continued evolution towards more integrated, data-driven processes. That means safer outcomes, whether it's designing out silica dust exposure at the source or simulating complex work plans in VR before anyone sets foot on site.
Okay, let's wrap this up. It's been a fascinating journey through how PFS 11926 and BIM are transforming construction safety.
We've seen the shift from paper to proactive, intelligent data.
Exactly. From that IUSG risk cycle, identify, use, share, generalize, to amazing real-world tools like 4D modeling, VR training, and Kobe for long-term management.
The examples like the M5 motorway, Victoria Station, Team 2100 really show the impact.
They do. It's about reducing risk, boosting efficiency, and creating a more sustainable built environment. And hopefully this deep dive gives you, our listeners, a solid framework to understand and even advocate for this safer, smarter, collaborative future.
Absolutely, because ultimately this affects everyone.
Which brings us to a final thought, if we connect this all together.
Right.
What does this shift towards a truly smart, data-driven, inherently safer built environment really mean for everyday life?
Yeah, think about the person working on that site or the person living or working in that finished building years later. How does this digital transformation impact them directly? And maybe for you listening, how can you use these ideas, collaboration, data, proactive design in your own work to champion this change and help build a safer, more resilient future?